Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You are a security administrator at your organization. You need to restrict service account creation capability within production environments. You want to accomplish this centrally across the organization. What should you do? The options are: Option A, use Identity and Access Management (IAM) to restrict access of all users and service accounts that have access to the production environment. Option B, use Organization Policy Constraints/IAM. Disable Service Account Key Creation Boolean to disable the creation of new service accounts. Option C, use Organization Policy Constraints/IAM. Disable Service Account Key Upload Boolean to disable the creation of new service accounts. Option D, use Organization Policy Constraints/IAM. Disable Service Account Creation Boolean to disable the creation of new service accounts.
To arrive at the correct answer, we focus on the keywords, restrict service account creation, centrally across the organization.
The correct answer is option D, use Organization Policy Constraints/IAM. Disable Service Account Creation Boolean to disable the creation of new service accounts.
Why is this correct? D. Applying the Organization Policy Constraints/IAM. Disable Service Account Creation Boolean is the correct method to centrally and effectively disable the capability to create new service accounts across the specified environments. Why are the others incorrect? A. Modifying IAM roles individually is not a centralized policy control, is error-prone, and is difficult to maintain at scale across an entire organization. B. The Constraints/IAM. Disable Service Account Key Creation constraint prevents the creation of new service account keys, but it does not stop the creation of the service accounts themselves. C. The Constraints/IAM. Disable Service Account Key Upload constraint prevents users from uploading public keys to service accounts, it does not prevent the creation of new service accounts.
You are part of a security team that wants to ensure that a cloud storage bucket in Project A can only be readable from Project B. You also want to ensure that data in the cloud storage bucket cannot be accessed from or copied to cloud storage buckets outside the network, even if the user has the correct credentials. What should you do? The options are: Option A, enable VPC Service Controls, create a perimeter with Project A and B, and include Cloud Storage Service. Option B, enable Domain Restricted Sharing Organization Policy and Bucket Policy only on the Cloud Storage Bucket. Option C, enable private access in Project A and B networks with strict firewall rules to allow communication between the networks. Option D, enable VPC peering between Project A and B networks with strict firewall rules to allow communication between the networks.
To arrive at the correct answer, we focus on the keywords, Cloud Storage Bucket in Project A, readable from Project B, cannot be accessed from or copied to cloud storage buckets outside the network, even if the user has the correct credentials.
The correct answer is option A, enable VPC Service Controls, create a perimeter with Project A and B, and include Cloud Storage Service.
Why is this correct? A. VPC Service Controls create a secure perimeter around resources. Including Projects A and B in the cloud storage service, and a perimeter prevents data exfiltration to external buckets, even if valid credentials are used. Why are the others incorrect? B. Domain Restricted Sharing restricts IAM identities, and Bucket Policy only enforces uniform access. They do not prevent authorized users from copying data to external buckets. C. Private Google Access allows instances to reach APIs via internal IPs. Firewall rules control VPC traffic but cannot restrict cloud storage API access or prevent data exfiltration. D. VPC peering connects networks, but cloud storage is accessed via Google APIs. Network firewalls cannot control access to these APIs or prevent data copying to outside buckets.
Your team needs to make sure that a compute engine instance does not have access to the internet or to any Google APIs or services. Which two settings must remain disabled to meet these requirements? Choose two. The options are Option A, Public IP. Option B, IP forwarding. Option C, Private Google access. Option D, Static routes. Option E, IAM network user role.
To arrive at the correct answer, we focus on the keywords, compute engine instance, does not have access to the internet, or to any Google APIs or services, settings must remain disabled.
The correct answers are Option A, Public IP, and Option C, Private Google access.
Why is this correct? A public IP address allows an instance to communicate directly with the internet. Disabling it fulfills the requirement to prevent internet access. C. Private Google access enables VMs without external IP addresses to reach Google APIs and services. Disabling this setting ensures the instance cannot access them. Why are the others incorrect? B. IP forwarding allows an instance to send and receive packets with non-matching IP addresses. It does not govern the instance's own access to the internet or Google APIs. D. Static routes direct traffic within the network. While they control routing paths, they are not the settings used to disable internet or API access. E. The IAM network user role grants permissions to use network resources. It is an authorization control, not a network configuration setting that disables access.
Which two implied firewall rules are defined on a VPC network? Choose two. The options are Option A, a rule that allows all outbound connections. Option B, a rule that denies all inbound connections. Option C, a rule that blocks all inbound port 25 connections. Option D, a rule that blocks all outbound connections. Option E, a rule that allows all inbound port 80 connections.
To arrive at the correct answer, we focus on the keywords, implied firewall rules, defined on a VPC network.
The correct answers are Option A, a rule that allows all outbound connections, and Option B, a rule that denies all inbound connections.
Why is this correct? A. Google Cloud VPC networks include an implied allow egress rule, enabling instances to send traffic to any destination by default. B. Google Cloud VPC networks include an implied deny ingress rule, blocking all incoming traffic to instances by default. Why are the others incorrect? C. Google Cloud blocks outbound port 25 to prevent spam, not inbound port 25. Moreover, this is a platform-level restriction rather than an implied VPC firewall rule. D. The implied egress rule permits, rather than blocks, all outbound connections from the VPC network. E. There is no implied rule allowing inbound port 80 traffic, all incoming traffic is blocked by the implied deny ingress rule until explicitly permitted.
A customer needs an alternative to storing their plain text secrets in their source code management (SCM) system. How should the customer achieve this using Google Cloud Platform? The options are Option A, use cloud source repositories and store secrets in Cloud SQL. Option B, encrypt the secrets with a customer-managed encryption key (CMEK) and store them in cloud storage. Option C, run the Cloud Data Loss Prevention API to scan the secrets and store them in Cloud SQL. Option D, deploy the SCM to a compute engine VM with local SSDs and enable preemptible VMs.
To arrive at the correct answer, we focus on the keywords, alternative to storing their plain text secrets, source code management, SCM, system, Google Cloud Platform.
The correct answer is Option B, encrypt the secrets with a customer-managed encryption key, CMEK, and store them in cloud storage.
Why is this correct? B. This provides a secure alternative by encrypting secrets before storage, using CMEK for control over the encryption keys, and utilizing cloud storage for durable, scalable storage of the encrypted secrets outside of the SCM. Why are the others incorrect? A. Cloud SQL is a relational database and not designed for secure secret management. While Cloud Source Repositories is an SCM, simply moving plaintext secrets to Cloud SQL does not inherently secure them. C. Cloud DLP is used to identify and redact sensitive data, not to manage or encrypt secrets securely. Furthermore, Cloud SQL is not the appropriate service for secret management. D. This only changes where the SCM is hosted and does not address the core issue of securely storing plaintext secrets. Additionally, preemptible VMs are unsuitable for hosting a reliable SCM.
Your team wants to centrally manage GCP IAM permissions from their on-premises Active Directory service. Your team wants to manage permissions by AD group membership. What should your team do to meet these requirements? The options are: Option A, set up Cloud Directory sync to sync groups, and set IAM permissions on the groups. Option B, set up SAML 2.0 Single Sign-On, SSO, and assign IAM permissions to the groups. Option C, use the Cloud Identity and Access Management API to create groups and IAM permissions from Active Directory. Option D, use the Admin SDK to create groups and assign IAM permissions from Active Directory.
To arrive at the correct answer, we focus on the keywords: centrally manage GCP IAM permissions, on-premises Active Directory service, manage permissions by AD group membership.
The correct answer is option A, set up Cloud Directory sync to sync groups, and set IAM permissions on the groups.
Why is this correct? A. Google Cloud Directory Sync, GCDS, is the recommended tool to synchronize users in groups from an on-premises Active Directory to Cloud Identity, enabling you to manage IAM permissions by AD group membership. Why are the others incorrect? B. SAML 2.0 SSO is used for authentication, not for synchronizing groups or users from Active Directory to manage IAM permissions. C. While the IAM API manages permissions, it does not synchronize users or groups from an on-premises Active Directory. A synchronization mechanism like GCDS is required. D. The Admin SDK can manage users in groups, but building a custom synchronization solution is unnecessary when Google Cloud Directory Sync provides this functionality natively.
When creating a secure container image, which two items should you incorporate into the build if possible? Choose two. The options are: Option A, ensure that the app does not run as PID1. Option B, package a single app as a container. Option C, remove any unnecessary tools not needed by the app. Option D, use public container images as a base image for the app. Option E, use many container image layers to hide sensitive information.
To arrive at the correct answer, we focus on the keywords: secure container image, incorporate into the build.
The correct answers are option B, package a single app as a container, and option C, remove any unnecessary tools not needed by the app.
Why is this correct? B. Packaging a single application per container limits the blast radius of a potential compromise and adheres to the principle of isolation. C. Removing unnecessary tools minimizes the attack surface by eliminating utilities that could be leveraged by an attacker if the container is breached. Why are the others incorrect? A. While PID1 issues affect signal handling and zombie process reaping, running as PID1 is not inherently a security vulnerability. D. Public container images often contain unpatched vulnerabilities or malicious payloads. You should use trusted, verified, and minimal base images instead. E. Container layers are easily inspectable. Adding layers does not encrypt or hide sensitive information, which should never be stored in the image.
A customer needs to launch a 3-tier internal web application on Google Cloud Platform, GCP. The customer's internal compliance requirements dictate that end-user access may only be allowed if the traffic seems to originate from a specific known good CIDR. The customer accepts the risk that their application will only have SYN flood DDoS protection. They want to use GCP's native SYN flood protection. Which product should be used to meet these requirements? The options are Option A, Cloud Armor. Option B, VPC Firewall Rules. Option C, Cloud Identity and Access Management. Option D, Cloud CDN.
To arrive at the correct answer, we focus on the keywords internal web application, originate from a specific known good CIDR, SIN flood DDoS protection.
The correct answer is option B, VPC Firewall Rules.
Why is this correct? B. VPC firewall rules can restrict access to specific CIDR ranges. Also, GCP's underlying network infrastructure inherently provides basic SIN flood protection for all instances, making this the correct choice for an internal application. Why are the others incorrect? A. Cloud Armor provides advanced DDoS protection and WAF capabilities but is designed for external load balancers, not internal applications. C. Cloud Identity and Access Management (IAM) is used for managing user identities and resource permissions, not for network-level IP filtering or DDoS protection. D. Cloud CDN accelerates content delivery for external users and does not provide CIDR-based firewall rules or network-level DDoS protection for internal traffic.
A company is running workloads in a dedicated server room. They must only be accessed from within the private company network. You need to connect to these workloads from Compute Engine instances within a Google Cloud Platform project. Which two approaches can you take to meet the requirements? Choose two. The options are Option A, configure the project with Cloud VPN. Option B, configure the project with Shared VPC. Option C, configure the project with Cloud Interconnect. Option D, configure the project with VPC peering. Option E, configure all Compute Engine instances with private access.
To arrive at the correct answer, we focus on the keywords dedicated server room, private company network, connect to these workloads from Compute Engine instances.
The correct answers are Option A, configure the project with Cloud VPN. And Option C, configure the project with Cloud Interconnect.
Why is this correct? A. Cloud VPN establishes a secure IPsec tunnel over the public internet, enabling private connectivity between your Google Cloud VPC and the on-premises dedicated server room. C. Cloud Interconnect provides a direct, high-capacity, low-latency physical connection between the on-premises private network and your Google Cloud VPC, avoiding the public internet. Why are the others incorrect? B. Shared VPC is used to share a VPC network across multiple projects within Google Cloud, not for connecting to an external on-premises network. D. VPC peering is designed to connect two separate VPC networks within Google Cloud, not for establishing connectivity to an on-premises dedicated server room. E. Private Google Access allows internal IPs to access Google APIs and services. It does not facilitate private connectivity to an on-premises network.
A customer implements Cloud Identity Aware Proxy for their ERP system hosted on Compute Engine. Their security team wants to add a security layer so that the ERP systems only accept traffic from Cloud Identity Aware Proxy. What should the customer do to meet these requirements? The options are Option A, make sure that the ERP system can validate the JWT assertion in the HTTP requests. Option B, make sure that the ERP system can validate the identity headers in the HTTP requests. Option C, make sure that the ERP system can validate the X forwarded for headers in the HTTP requests. Option D, make sure that the ERP system can validate the user's unique identifier headers in the HTTP requests.
To arrive at the correct answer, we focus on the keywords Cloud Identity Aware Proxy, only accept traffic from Cloud Identity Aware Proxy.
The correct answer is Option A, make sure that the ERP system can validate the JWT assertion in the HTTP requests.
Why is this correct? A. IAP passes user identity to the backend via a JSON Web Token, JWT, in the HTTP request header. To securely verify that traffic came specifically from IAP, the backend application must validate the signature and payload of this JWT assertion. Why are the others incorrect? B. Standard identity headers are easily spoofed if a user bypasses IAP and directly accesses the backend. Only the cryptographically signed JWT ensures secure verification. C. The X-forwarded for header only contains client IP addresses, which can be spoofed, and it provides no cryptographic proof that the traffic actually passed through IAP. D. Simple user identifier headers lack cryptographic signatures and can be easily spoofed by malicious actors bypassing IAP to send requests directly to the compute engine backend.
A company has been running their application on Compute Engine. A bug in the application allowed a malicious user to repeatedly execute a script that results in the Compute Engine instance crashing. Although the bug has been fixed, you want to get notified in case this hack reoccurs. What should you do? The options are: Option A, create an alerting policy in Stackdriver using a process health condition, checking that the number of executions of the script remains below the desired threshold. Enable notifications. Option B, create an alerting policy in Stackdriver using the CPU usage metric. Set the threshold to 80% to be notified when the CPU usage goes above this 80%. Option C, log every execution of the script to Stackdriver logging. Create a user-defined metric in Stackdriver logging on the logs, and create a Stackdriver dashboard displaying the metric. Option D, log every execution of the script to Stackdriver logging. Configure BigQuery as a log sync, and create a BigQuery scheduled query to count the number of executions in a specific time frame.
To arrive at the correct answer, we focus on the keywords: compute engine, repeatedly execute a script, get notified.
The correct answer is option A, create an alerting policy in Stackdriver using a process health condition, checking that the number of executions of the script remains below the desired threshold. Enable notifications.
Why is this correct? A. Stackdriver alerting policies with a process health condition allow you to monitor specific script executions and actively notify you when a defined threshold is exceeded. Why are the others incorrect? B. CPU usage is a generic metric. High CPU usage can be caused by legitimate workloads, leading to false positives rather than identifying the specific script. C. While logging and dashboards provide visibility, they require manual monitoring and do not provide active notifications when the script is executed. D. BigQuery scheduled queries can analyze logs retrospectively but do not provide real-time, proactive notifications for security events.